In this lecture, I will teach you how to create the rich forms of the ear from imagination for the rest of your life. I'm gonna show you exactly how and where the ear is attached to our skull, what anatomical parts make up the ear, what forms are important, and how to turn these forms into a beautiful sculpture. By the end of this lecture, you will be able to create the human ear and variations of the ear from memory with ease. After each lesson, I'm gonna ask you to do a short assignment. So don't just binge watch the entire course from start to finish, and take you some time to do these assignments. This is very, very important because it helps you to transfer the newly gained technical knowledge into real and practical knowledge. That's the foundation of every craft. You are probably asking why I start with the ear instead of the whole head. And the answer to this is easy. The task of sculpting the entire head can be pretty daunting, especially if you have never done this before. And under these circumstances, I can guarantee that you fail fast and that you probably become discouraged by your first results. And for this reason, I start with the ear simply to take away some of the initial pressure to succeed on your first try. And in this case, we can also take advantage of the complex forms of the ear, because you cannot exactly tell what's right and what's wrong, even if you are not able to nail the forms perfectly on your first try. As long as you get the most important forms of the ear right, it will always look like an ear. And this should also encourage you to approach all other parts of the head or all other parts of the human figure with confidence. Now, before I continue with explaining the function and the location of the ear, let me quickly explain the difference between the term shape and form, as I'm gonna use these two words a lot in this lecture. So throughout this lecture, I mainly use two terms to describe an object, and this is shape and form. And even if they describe something different, they still meet on a certain level. So let me quickly explain what I mean by this. If I draw a circle on the whiteboard here, or if you do the same on a piece of paper, it looks something like this, right? And I consider this as a two-dimensional shape. So let me quickly note this here, 2D shape, right? So if I repeat this one more time and extend our two-dimensional grid into 3D by adding an additional axis, I turn the circle shape into a three-dimensional form or a sphere. So it looks like this. I'm drawing the circle again, and now I'm adding a ground shadow, like so, and the shadow side over here, right? And the highlight would be here, light is coming from this direction. And I consider this as a three-dimensional 3D form, right? So of course, it works the same way with another shape. If I draw a square type shape, for instance, and extend it into 3D space, I turn it into a box. But of course, you get the idea. So it's the same principle. When I now combine more forms, I create more complex volumes. So let's say I place one sphere in front of another, right? Then it looks a little bit like this. So I can add the ground shadow again. And here we have our shadow side and the highlight, right? And if you forget about the shading for a second and only focus on the shape these complex volumes are creating, we end up with something like this, right? So one sphere in front of the other. And in this case, I describe this two-dimensional shape that is laid out in 3D space as the outline of an object, right? So this is the outline of a three-dimensional object. So let me briefly recap what we have just learned. We have two-dimensional shapes, right, like this circle here, that can be extended into three-dimensional forms and volumes. And whenever I combine these basic forms into more complex volumes and take a look at the shape they create in 3D space. I refer to this as the outline of an object. In the next chapter, I will talk about the connection between form and function. Before I show you what the function of the ear is, I would like to talk about the statement or the principle, or you can even describe it as a law that you can find everywhere in nature, and this is form follows function. So let me quickly note this here. Form follows function. So this is a relationship that was described by the American architect Louis Sullivan, and it basically means that there is no coincidence in nature when it comes to form. So every form or every structure in nature is determined by its function. So even if the term form comes first in this statement and function is second, by having the verb follows in between, this one makes form dependent from function. So let's say if we get rid of the term follows, we can write the statement like this. Function, form. So now function comes first and form comes second. And function comes first because it describes why something exists, and form comes second because it is the logic consequence of function. If we take a look at this principle in nature, we can take this even one step further and conclude that function equal form, right? So this means that whenever function does not change, form does not change, or vice versa. Whenever function changes, also form changes. Now let's take a look at this principle on a more practical example and how food intake and the bite force really form and define the forms of our skull. And as you know, the lower jaw or the mandible is a separate bone that is connected with two joints to the rest of the skull. And basically 4 muscles on each side of the skull are responsible to build up a chewing pressure. And we need this chewing pressure to grind food between our teeth because our stomach can only handle bite-sized pieces, right? So basically we have 2 big muscles on the outside and 2 smaller muscles on the inside. There is the masseter muscle that starts at the angle of the mandible and goes up and inserts into the zygomatic arch here. And then there's the big temporalis muscle that starts at this line here, goes down and behind the zygomatic arch and inserts at this branch of the mandible. And together they are able to build up a chewing pressure that's around 80 kilograms, which is a crazy amount if you think about it. Now, when you look at the skull from the front, the upper jaw or the maxilla is constructed in a way that it can equally level off the chewing pressure into the bony structure of the upper skull right here. So basically the chewing pressure gets equally leveled off on the inside and on the outside of the maxilla and is equally strained into the upper part of the skull, right? So as you now know that form follows function, I'm gonna show you the function of the ear in the next chapter and talk about how this function really defines the distinctive forms of the ear. As you now know that form follows function, let's take a quick look at the function of the ear. Acoustic perception is one of the 5 sensory perceptions of the human body, and the ear as an organ actually consists of 3 parts. We have the outer ear, so that's the visible part that is attached to our skull, and it's actually the only part that's relevant for sculpting. Then we have the middle ear and the inner ear. And the ear itself is responsible for two types of perception. We have the acoustic perception that happens in the middle ear, where sound waves are transformed into electric signals that can be understood by our brain. And we have the sense of balance that is calculated in the inner ear. Now, why do we have one ear on each side of our head? If one stops working, we still have a second one for acoustic perception, right? But this is not true, or this is not the main reason. The reason why we have two ears is that it allows us to locate where sound is coming from. So let me quickly draw a very simplified version of our head. Right? Then we have an ear on each side of it, and there's a distance between the ears of approximately 21.5 centimeters. And when a sound source is coming from a certain direction, let's say it's coming from here, it reaches this ear insignificantly earlier than this one. And based on this slight delay, our brain is able to locate where the sound source is. So if it is coming from the left or the right, or if the sound source is in front of us, if the sound waves are reaching our ears simultaneously. And that's the reason why we have two ears. Now, why has our ear such a distinctive form? So if you look close, it is arranged around the outer ear canal. That's the opening at the side of our skull. And it looks a little bit like a funnel where sound waves get channeled into the outer ear canal. This is true, but again, that's not the main reason. It's a little bit more complex than this. The outer ear is actually a resonance body. So this means it vibrates or it oscillates a little bit differently depending on the direction of the sound. And I'm not talking about left and right here anymore. I talk about distinctive directions like in front of us, above us, below us, and behind us. And based on these directions, the resonance body vibrates in a way that it changes the frequency of the sound. And based on these changes, our brain can exactly tell where the sound source is located. And this is mainly the reason why the ear has such distinctive forms. In the next chapter, we will take a look at the main shapes of the ear. Now, let's take a look at the main shapes of the ear. And like I've already mentioned in the previous chapter, the structure of the ear is arranged around the outer ear canal, a little bit like a funnel that allows to channel sound waves into the outer ear canal, right? And if you look at the ear from the side, it has this typical 9-like shape to it. So if I draw in the outline or the outer border of the ear, it looks something like this. Starts here, goes up, curves over, comes down, and ends somewhere here. And the upper part until here is made out of cartilage tissue, and the lower part, where the lobe is attached to the cartilage part, it is made out of fatty and skinny tissue, right? And the outer ear canal is located somewhere here in this example. And I also want to point out that when you look at the ear from the side, it is also attached in a slight angle to the skull, right? So it leans backwards a little bit between 15 to 20 degrees. And then there's another a very important internal shape, and that's a Y-like shape that is located here. It looks a little bit like this. And if you combine the 9-like shape together with a Y-like shape, it already starts to look like a very simplified version of an ear. So I can draw this again from the front, and in this case the ear is also attached, slightly angled to the skull, and we have here this slight 9-like shape or 9-like outline again. And if I then draw in the Y-like internal shape, it again already starts to look like a very simplified representation of the ear. In the next chapter, I will talk about the different variations of the human ear, and we will compare the human ear with animal ears. This is a collection of 3D scans of the ear that demonstrates that the perfect ear does not exist. But keep in mind that even if every ear looks quite different, they all share the same shapes and forms to a certain degree. So if I zoom in, I can draw in the 9-like shape that we have covered in the previous chapter, like so. So it comes up, it curls over, it goes down, the cartilage part of the ear ends here, and the skin and fatty tissue of the lobe starts in this area. And as you can see, we also have a slight angle here that's again between 15 to 20 degrees. And of course, we also can find the internal Y-like shape that is located here. And even if every ear looks different, on this example here, we can always find the 9-like shape again and the internal Y-like shape. These differences, and this is a cool thing, they do not only occur on the ear but on every part of the human body. So it's the same for the eyes, it's the same for noses, it's the same for the general form of the skull. So at the end of the day, these variations make every human being look unique. And there is also not a big difference between the male and the female ear, as the function is exactly the same. But it's usually a good idea not to emphasize the square forms of the female ear too much and keep it round and smooth. So we have 9-like shape, or a very square-like 9-like shape of the male ear. And again, the internal Y-like shape. And we have a smooth 9-like shape on the female ear, and again the internal Y-like shape. The difference between hearings in humans and animals is often visible externally. So birds, for example, lack external ears, or the pinna, as the external ear is also called. Even if the structure of the internal ear is very similar to us humans. So it becomes only visible when you carefully move away the feathers, and then the outer ear canal or the opening here becomes obvious. All mammals have outer ears, and many of them have the ability to move the pinna to help with location of sound. They come in different size and form and are sometimes huge compared to the rest of the body, like you can see on the example of the fennec or the desert fox. And some mammals use the structure of the ears also to regulate body temperature. Elephants do this by using their huge pinnas as fans for heat exchange. They also have the biggest ears of any living animals. That's it for this chapter. In the next one, I will briefly recap what we have just learned in this lesson before we then take a look at the first assignment. In this chapter, let me briefly recap what we have just learned in this lesson. I would like to teach you how to sculpt the ear in a way that you will never forget how to sculpt it for the rest of your life. We start with the ear simply to take away some of the initial pressure to succeed on your first try, because if we would focus on sculpting the entire head, then you will probably fail pretty fast, because this is a daunting and very complex task. So we stick to the ear first so that you gain confidence to address all other parts of the human head or the body. I describe an object as a two-dimensional shape when I focus on its two-dimensional outlines, and I consider it as a form or three-dimensional volume when it gets extended in space. When you combine different volumes together and focus only on the shape it creates in 3D space, I consider this as the outline of an object. Then we had a brief look on the principle that form always follows function. So form is dependent on function. This means where function does not change, also form does not change. You probably remember the example of how food intake affects the way the skull looks. And of course the same is also true for the ear. And when we take a look at the form of the ear, or why we have two ears, then it is always connected to function. We have two ears and the distance between them so that we can locate where the sound is coming from. And the distinctive form of the ear comes from the fact that it is a resonance body that oscillates or vibrates differently depending on the direction of the sound source or the direction where the sound is coming from, and based on these shifting frequencies our brain can pretty much distinguish exactly where the sound is coming from. To construct the basic shape of the ear, all you have to remember are two very important shapes. That's the 9-like shape when you look at the ear from the side and also slightly from the front, and we have an important internal Y-like shape. So if you combine this 9-like shape with a Y-like shape, you already get a very basic representation of the human ear. And last but not least, the perfect ear does not exist. So every ear looks slightly different, even if they all share the same core elements. In the next chapter, I will explain what the first assignment is. I'm gonna throw you in at the deep end here with this first assignment because it is very important that you determine your personal baseline early on. And for this reason, I want you to open the project folder and use the reference images in there to sculpt an ear. We all have already a picture, a pretty good picture actually, of an ear in our head because we are used to look at ourselves in the mirror and into many faces every day. And for this reason, I want to find out what you already know and what you are already able to do. Don't get me wrong, you don't have to deliver a polished sculpture. It's not about any fancy tools or techniques, and it shouldn't also take you longer than an hour. So use whatever tool you have available or whatever software you have available. Take the reference images and start doing the work. It's also totally fine if you feel a little bit uncomfortable doing this assignment and if you are not happy with the result. Actually, this is a good sign because this means that you feel that there is still room for improvement. So use the reference images from the project folder and start sculpting. If you don't want to start with your own mesh, I have included a very basic starter mesh saved as an OBJ, load it into Blender or ZBrush and start sculpting.